Section 3.1 in college algebra. Today we're talking about parabolas, stuff we should be pretty familiar with. Do a little factoring at the end or solving quadratics. They want to know when this graph or any quadratic graph is increasing or decreasing. To make it short and sweet, it says in the parabolas below, use a highlighter to highlight where the graph is increasing, then use a second color to where it's decreasing. If you want to use your pencil, I don't care, to make one dark and one squiggly or something. But check it out. Where is the graph increasing? That's where it's going up from left to right. Like if I was to trace this parabola with my highlighter, where would my parabola be going up from? Well, it's going down, 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 down. Wouldn't it be going up right there? Correct? Yes? No? Maybe? Where does that start from? 0. Does 0 count? No. 0 doesn't count because it's not increasing or decreasing at 0. And then where does it end at? To infinity. Cool. That's where that graph is increasing. Where is it decreasing? Different color. Doesn't it decrease from there to there? Right? Isn't that where that graph was going down at? So reading from left to right, it went from negative infinity up to 0. And 0 again does not count because 0, it's neither increasing or decreasing at that particular point. Cool? So let's do that on this guy. Where's he increasing? Wouldn't that be here, where that thing's going up from left to right? They went ahead and listed that cool ordered pair for us, and it's all about the x values, right? So from 2 to infinity. 2 doesn't count. The vertex never counts in these puppies. And then where's he decreasing at? That'd be here, from negative infinity to 2 not included. Go ahead and try this one. Where is he increasing? Where is he decreasing from? Increasing. Decreasing. Pretty simple stuff right there. Good? Going up from left to right, from negative infinity all the way to 3. Where does it go down? Starts at 3 all the way to positive infinity. People are confused. They're like, but that's going down to like negative infinity. It's not about the y values. It's about the x values. This is where x is 3. Here's where x is 4, x is 5, x is 6, x is 7, 8, 9, 10. Aren't the x values keep getting bigger and bigger and bigger and bigger, even though the y values are going down? That's where that was decreasing at. Okay? Good? Here, they tell you how to find the vertex of a parabola. Cool little formulas right there. The vertex, it's got to be in standard form right here. So you might want to make yourself some notes. If your parabola is in standard form, which is ax squared plus bx plus c, to find the x value of the vertex, this is the formula. X will equal the opposite of b over 2 times a. We'll come back and use this often. The way these worksheets are typed out is like all the notes are at the beginning. Then we'll go do the problems, and if you need to look something up, you'd have to flip back to the beginning kind of stuff. But it's like, how would you find the x value of the vertex? Here's the formula right here. But it must be in standard form for that to work. So whatever the b value is, take the opposite of it, divide it by 2 times that a value. Cool? Then, to tell if a graph opens up or opens down, it's all about the a value. If the a value is positive, that graph will open up, that parabola will open up. If the a value is negative, that thing will open down. That's all that this is all about. They use fancy phrases on your My Math Lab. Instead of say open up, they say concave up. And instead of saying open down, they say concave down, right? It's all about the a value. So let's dive into some problems. First thing they want to know here is is the function quadratic? Well, you know it's quadratic if it's the biggest exponent you see in there is a 2. Here's this guy. Is that a quadratic function? Yes or no? So that's not quadratic. That's a linear guy, right? Isn't that 4x to the first minus 3? That's linear. And then since it's not quadratic, we don't have to do part B or part C. Cool? Number 2, is that guy quadratic? Is the biggest exponent you see a 2 in that equation? Yes or no? Yep. So he is quadratic right there. So far, so good. Part B, determine if it's concave up or concave down. Open up or open down, you look at the a value. What is my a value? -5, so open up or open down? and we'll put concave down. Concave down. Then they want to know, will that graph have a minimum or a maximum? If it bothers you, it's like, man, I don't know. Didn't you just say that this parabola opens down? Make a little sketch. There's a parabola that opens down. Does it have a minimum or a maximum point? Maximum. Pretty simple. Cool? For 3 and 4, graph each quadratic function on your standard window, right? 10s all around. And then determine if you get a complete graph. So please pause the video and type that bad boy in for me real quick. This is what it looks like, correct? Does that give you a full picture of it? What it means is it already told you it's quadratic, so it better look like a parabola. You need to be able to see the vertex, the x-intercepts, and the y-intercepts. Do you see all of that stuff on this graph? Yes or no? Can't even tell that that's a parabola on the standard window, correct? So does it give you a complete graph? Yes or no? No. That's all that it asks, right? Does it give you a complete graph? Other one, he is a parabola. It told you so, right? It's a quadratic. Please graph him on the standard window. I bet he looks like that, correct? Most people would say, yes, that's a complete graph. The answer is no. Why is this not a complete graph? I do see the parabola. I do see the vertex. There are no x-intercepts, which is totally possible, right, because the parabola opens up and it's shifted above the x-axis. There's no x-intercepts. But you can't see one other thing. What can't we see? The y-intercept. I do not see the y-intercept. So this is not a complete graph. Meaning we'd have to change our window on both of these to really see what we wanted to see. Okay? All those critical points that when you made those sketches last year or whenever in Algebra 2, we had to plot those. So, no. Write the equation of this in vertex form. This is vertex form right here. Y is all by itself. A value is still the A value. X minus h, quantity squared, plus k, where your vertex is the ordered pair hk. This is the vertex every time. Notice the negative sign in front in that formula, meaning the x value of the vertex is the opposite of what you see in this position. The y value of the vertex, what you see is what you get with that k value. So they gave me an ordered pair, right? They want to pass through this. So this is like an xy value right here. I think it's very helpful to put xy. And they also gave me the vertex. The vertex of a parabola is always written hk, so I'm going to put an hk near that, either above or below. And then me personally, I'm old school. I always write the formula down first. Your choice. But when it comes to the work shown, I want to see the work shown. There are 5 variables in this equation. There's a y, there's an a, there's an x, there's an h, and there's a k. We know 4 of them. We know an x, we know a y, we know an h, and we know a k. What we do not know is the a value, correct? So let's substitute all of this stuff into this formula. Y was 0 in the point that they gave me. A, that's the thing I don't know, times the quantity of x, which is 4, minus h, h is 2. That's got to get squared as a quantity, plus k, which is a minus 4. Y'all cool with how I substituted in? And I labeled my stuff that they gave me, put them in the formula. Then I follow the order of operations. I got to do this part first. What's 4 minus 2? It's 2. Doesn't that have to get squared also? What do you get right there? 4. And it's being multiplied by a, so you got to keep that a with it. Then there is a minus 4 also. Y'all cool with that? I did 2 things at one time. I took 4 minus 2. I got 2 in my brain. I squared it and got a 4. And I have it times a, so I rewrote it as 4a instead of a4. I see this all the time, though. People write this, and then they go ahead and think that they can subtract those from each other. And you're violating the order of operations, because isn't there multiplication going on right there? You can't do that. So now let's solve for a. We add 4 to both sides. And a, of course, equals 1. A lot of people stop there. They're not done. You need to write the equation in vertex form. So, boom, 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 substitute back in. Y equals, A was 1, times the quantity of x minus the h value of your vertex, which is 2, minus 4, because that's your k value. This is the equation of that parabola in vertex form. Good with that? Yes? Cool. That's when they gave you a point in the vertex. I feel totally worth the time to put the x, y, h, k. But there's another problem right here. They give me the equation of a parabola, but it's in standard form already. They want me to put it in vertex form. Would you believe in vertex form you need to know two things? You need to know the vertex, obviously, and you need to know the a value. That's all you need to know. Question for you. Do you know the a value? When it's in standard form, do you know the a value? What's the a value? A is 2. So why don't we write that down? A is 2. Cool. I need to know the vertex now. Well, this is in standard form. I can find the x value of the vertex with a cool little formula. I will say the x value of the vertex is the opposite of b over 2 times a. Which, what's the opposite of b? 8. And 2 times a is 4. So the x value of my vertex is at 2. AKA, that's h right there. That's the x value of my vertex. Now I need to figure out the y value of the vertex. You could do it many ways. You could punch this in your graphing calculator and substitute 2 in, or you could just type in 2 times 2 squared minus 8 times 2 plus 5. You just substitute 2 in for x, because isn't that the x value of your vertex, and you're trying to find y? So do that for me. Punch that in, because I don't know what it is without looking here. So when you do that, you get negative 3. So I know my vertex. I'm going to make a note of that. Vertex is at 2, negative 3. Please write the equation of this parabola in vertex form when you know a is 2 and the vertex is 2, negative 3. All right, so let's just follow this formula. Let me erase all this stuff, get it out of the way. I know the vertex is in that hk, correct? And I know the a value. So it would be y equals a, which is how much? Times the quantity of x minus h squared plus k. H was 2, yes. K was negative 3. Box them up. Hot dogs? Yay for parabolas. Cool. Give the coordinates of the vertex of the graph of this function. Is it in vertex form or standard form? What form is that in? Vertex form or standard form? That's in vertex form. Meaning you can look at that directly and tell me where the vertex is at. Is it at 10, negative 6, negative 10, negative 6, negative 6, 10, or negative 6, negative 10? It's got something to do with these 10s and 6s, correct? What is the vertex of this parabola? It's the opposite of this guy, right, because of that minus involved with that formula. And then what's this one? Is it 6 or negative 6? Negative 6. What you see is what you get with that one. So give the coordinates of the vertex of the graph, then graph it on a window that includes the vertex. Cool. So now let's see if we can figure out a window. First thing I want to know about this parabola, I do know where the vertex is, correct? But I also want to know if it opens up or opens down. How does this parabola open, up or down? Always look at the a value. What's the a value? 1, correct? So doesn't this bad boy open up, correct? If the vertex is at negative 10, negative 6, let's see what kind of window we really need to graph this puppy. Let's type him in. Let's get rid of you, man. Slide over just a little bit. Minimize. 1 second for me. Let's type him in. Y equals, clear all my stuff out. Sorry, guys. You got to type the parentheses. So it's x plus 10, quantity squared, minus 6. I don't think that standard window is going to work. That's why we did that earlier. Zoom 6. I mean, there it is. I don't see it all. The vertex is at negative 10, negative 6, way over here, correct? What do I need to change on my graph? My x minimum. So we might as well go big or go home. I'm going to go straight to negative 30 right away. And then I'll change my scale to go by, I don't know, whatever, something else. 5s maybe, who knows. Graph. Much better. Sort of. What don't I see? Y-intercept. So that's Y maximum, correct? Let's go big or go home. Let's see what it looks like. Let's go to 50 and go by 10s. Go wrap him. Still don't see it. Son of a gun. Looks like I went home. Go big or go home. Let's go to 100. Bigger still? That's pretty close, right? It's about right there. I'm fine with that. You know, if you want bigger, even better. So they just want you to sketch that. So I will sketch that. And tell me what your window parameters were. This was 100. This one was 10 on mine. This is at negative 10. And this is at negative 30, right? If you don't know, hit your window button. It'll tell you all that stuff. And then just make yourself a sketch. It looks something like that. All that they really cared about was what was the window, right? If they asked you to type it in, you would type the window in like this. That's your X window, correct? And then they'd probably have the word by right there for you. And then you'd go negative 10 to 100. Like that's how the window is typed. All cool in the neighborhood? Awesome. Next guy. Is he in standard form, vertex form, or actually none of the above? None of the above. It's not in standard form, but it's definitely not in vertex form either, because you don't have the parentheses. Why is he not in standard form? Because the x squared stuff doesn't come first. So you want to switch them around a little bit. They want us to find the coordinates of the vertex. Obviously, you could graph that and calculate it, you know. I mean, it's all good in the neighborhood. But I'm going to use the trick to find the x value first, because the whole point of these is they probably don't fit on the standard window, so you'd have to hunt and change around your window all over the place. So x value of the vertex, opposite of b, over 2 times a. X value of my vertex is at a 2. Now I at least am in the ballpark of where my x scale should be. Cool? Find the y value of the vertex, substitute in. So I'm going to go with, quit out of here, negative 3 times 2 squared plus 12 times 2. I'm subbing that in. The y value of the vertex is at 12. That tells you right then and there you're not going to fit on the standard window. The vertex is at 212, so we'll label him vertex 212. Is he open up or open down? Down, because the a value is a negative 3, right? So I'm going to go type him in, and you find me a nice window for it. Pause the video, give it a try, meet back with me once you found a good window. My window was from 15 at the y max, and then 10s all around on the other ones, and my sketch. Come on, dude. Looked like, oh, I can't even do it. Like this. Something like that. Nice? Yeah. Same thing. Find the x-coordinate of the vertex of the graph. Cool. Standard form or vertex form? Standard form. Find the x value of the vertex. I'm always the person that writes this formula down. I don't care if you write the formula down or not, but that's just the way I've been rolling for the past 12 years, so I'm going to keep rolling that way. Opposite of b over 2 times a, which I made a mistake. That should be 4. Get out of here. Sorry. That should be 4. X value of the vertex is at 10. That's what part A wants, right? Find the x-coordinate of the vertex. Then set a viewing window so that the x-coordinate of the vertex is near the center of the window and the vertex is visible. Then graph the given equation. Well, you don't have to find the vertex in these problems. They don't tell you to. I think it's a pretty good idea to do that because it makes finding your window a whole lot easier. So let's put 10 in for this, and let's see what that bad boy turns out to be. Please do that for me. When you substituted 10 in, what did you get for your vertex? Negative 190. That saved me a ton of time, in my opinion. I know my vertex is there. Now I have a good idea of where I need to dead center this thing. The vertex is supposed to be in the dead center, so if my y value is at a negative 190 and this puppy opens up, correct? Let's make I better type the actual equation in first. 2x squared minus 40x plus 10. Let's make my y scale. That's supposed to be in the dead center. That's basically negative 200, correct? So what do I need to go down to? Negative 400. Because the instructions asked for it to be like in the dead center-ish, close to the dead center. So if this is where the vertex is at, then there we go. And then the x value of the vertex is at 10, so I know that my x maximum should be at 20. That. Cool. I got to change my scale. Y max, I'll just go to 10 again. And my scale, I'll go by 10. Let's go by 50s. And let's graph him. See how it looks. Pretty close. Pretty decent guy. Sketch it, because they're asking you for the window. This was 10. Oops, that's not a good sketch. Pretty decent sketch. Basically asking for the window. Let's do that again. Find the x value of the vertex for me. Since that's in standard form, opposite of b over 2 times a. Now that you have the x value of the vertex, I would find the y value of the vertex by substituting negative 11 in for x. You get a major vertex of negative 11, 375. So my window, my x value is at negative 11. So my negative minimum, I'm going to double that. That's negative 22. I'm basically going to go to negative 25. And I'll just go to 10. This parabola opens down, correct? So my y value is at 375. That would be doubled. Since it opens down, I want to do my y max to be 750. And then this guy can just go down to whatever, negative 100. There's no real parameters on the other one. You just want to double these numbers to find whichever one you need, the max or the min. Hit graph and see if it looks good. Uh-oh, what did I do wrong? Oh, because it opens up and negative. Did I type it? Oh, I didn't type it in. That's what I didn't do. That's what I didn't do right. If you type it in, it'll be on a good window. But I didn't actually type this equation. Negative 3x squared minus 66x x negative 3x squared minus 66x plus 12. That should look a whole lot better. Come on. Come on. Come on. Come on. Way better. Sorry, my bad. Cool. Awesome. Then you make your sketch. Next, consider this function. Part A, please find the x-coordinate of the vertex. Do that for me. Over 2 times a, 32 over negative 0.4. Is that right? Negative 0.4, 2 times a. And what did y'all get for the x value of the vertex? Negative 80. Cool. Then this is a Math Excel or my Math Lab problem. So it says set the viewing window so that the x-coordinate at the center is visible and graph the given equation. So that's choice B down here. They've given you some 3 options, right? You know the x value of the vertex is at -80, okay? And this parabola opens down. I would look at all 3 of them first. If there's any that open up, you know you can eliminate those. You know this is a horrible window because you don't see the vertex, correct? So the question is, out of these 2, which one's right? Well, I probably better punch it in and see which window works. Well, dear Lord, they tell me the windows, so I would try them both and see which one works. So, go ahead. Try part B first, see if that looks like it. So I'm trying choice B right here. I got my window set what they said. I'll hit graph on it, see if that's what it looks like. I think that's what it looks like. Isn't that what it looks like? Looks like choice B is our answer. If you try to do it on choice C, it just wouldn't work. What's the difference between those 2? The window. See, the window, this is backwards, right? And it just doesn't show the right thing is why that's wrong. So always easy to just graph them both. Yeah! Story time. If a ball is thrown upward at 39.2 meters per second from the top of a building that is 30 meters high, this equation gives you what happens to that ball, where t is the number of seconds after the ball is thrown. Find the t-coordinate and s-coordinate of the vertex of this quadratic equation. Well, xy, right? T is the x values, correct? S is the y values. To find the x value of the vertex, I'm going to do opposite of b over 2 times a. Opposite of b. Realize where b is. They don't have this in the correct form. B is this, 39.2, so I want the opposite of that. A is negative 9.8 because that's in front of the t squared. So I need 2 times that, which is negative 19.6, is that right? And you punch that in, and you get t. Then you could punch that puppy back in if you want. You could go to your graphing calculator, graph the thing, and find the vertex. I would just substitute 2 in to find the actual y value of the vertex. So if you substitute 2 in for t, you can tell me what you get. .2 is what you're coming up with. I'm going to make a rough sketch of this. You know, I didn't even graph it, but I know what's going on with this. It's up to you if you want to make a rough sketch, but it helps explain the next 2 problems. Here's your x-axis and y-axis in the positive. It starts 30 feet off the ground, and then it does this. Woo! Right? It's a ball that's been thrown. We just found the vertex to be right here at 69.2. The little sketch helps me answer these questions. Explain the meaning of the coordinates of the vertex. What does this mean? Well, what's down here is time in seconds, and this is the height in feet, or meters, I guess. Meters, height in meters. What does 69.2 mean? At 2 seconds, the ball is 69.2 meters high, and there's something else that's special about that. That's true. After 2 seconds, the ball is 69.2 meters high, which is its maximum height. Right? That's the maximum height of the ball. So that's what we'll say after 2 seconds. The ball, you can put it however you want, reaches its maximum height of 69.2 meters, or is at 69.2 meters, which is its maximum height. Max height of 69.2 meters. After 2 seconds, the ball reaches its maximum height of 69.2 meters. Over what time interval is the function increasing? Right here. Isn't that where it is increasing? Correct? From where? Time interval, those are x values, correct? So it starts at 0 and it ends at 2, correct? Neither one is included because it's not increasing at 0, they haven't thrown it yet. It's not increasing at 2, it's maxing out at 2, so between 0 and 2. What does this mean in relation to the ball? What do you think? I'm sorry? Cool. From 0 to 2 seconds, right? We have to put that in there. The ball increases in height from 0 to 2 seconds. The ball increases in height between 0 and 2 seconds. That's all it means. The ball increases in height from 0 to 2 seconds. They give us 200 feet of fencing for a rectangular pen. So I drew a rectangle like it told me to. This is talking about the perimeter. The problem is we don't know any of the side lengths, correct? What you should know about a rectangle is if this side was 10, how long is this side right here? 10. Opposite sides are equal, correct? So would you agree that if all four sides have to add up to 200, that this side and this side should add up to how much? 100, correct? Is that cool with you, right? Because all four has to add up to 200 and equal sides. So let's make up something for this side. Let's call him x. Now that side is x. And you told me that this and this have to add up to 100, correct? If this was 10, wouldn't that be 90, right? If this was 20, this would be 80. Well, it's x. So how much is this? 100 minus x. Right, whatever it is. If this was 10, this is 100 minus 10. If this is 20, this is 100 minus 20. You all cool with that? I also feel you should put x here and 10 minus x here, just to kind of make it easier to see, because opposite sides of a rectangle are equal. What is the function of the area of the pen? Well, area, again, don't we need to take the length times the width? Yeah, sorry, 100 minus x. Area, length times width, correct? So I'm going to do something off to the side first. I'm going to say the area is the length, which I will call x, times the width, which is 10 minus x. And that's a quantity, because it's 100 minus x, sorry. That's the second time I've done that. 100 minus x. You with me on that? Got to be a quantity. I don't like it like this. I want to distribute. So this would be a equals 100x minus, what's x times x again? X squared. Meaning, this function is a what kind of function? Starts with a Q. That's a quadratic function, correct? I'm also going to rearrange him to put him in standard form. That x squared is negative, and the 100x is positive, and now he's in standard form. So here is my function. The area equals negative x squared plus 100x. Awesome? What is the maximum possible area of the pen? Because they could rearrange their fence however they wanted to, right? They could have went 10 by 90, and the area of that would be 900. They could have went 20 by 80, and the area of that would be 1600, and et cetera, et cetera, et cetera. If we graph this, it will give us all the possibilities of what the areas would work out. So let's go ahead and do that. Let's graph him real quick. Clear all this stuff out with negative x squared plus 100x. Is that right? And then let's make our window. We don't need any of that negative stuff, so let's go to negative 10. Let's go all the way up in x max. Let's just go to 500. And let's do that on a scale by, I don't know, at 50s, that's fine. Y min, negative 10 to 500. Again, let's see what that would look like. Scale going by 50s. Let's just see what that would look like. Too much and not enough. So I'll help you change it. Let's do our x window. Let's go to just 200. And our y max, let's go all the way up to 4,000. And I'll go by hundreds this time. Better. Okay? Every one of these points gives you a possible area. Where, oh where, would the maximum area be on this graph? Do you know anywhere where this graph maxes out at the vertex? So if we find the vertex, that's our maximum area. You could do the opposite of b over 2 times a. Since I got it graphed, I'm just going to calculate it real quick. That would be the maximum. Left bound. Please no. That's why I hate this calculator. It's still left of it. To the right. Yes. 50, 2,500, correct? But how do you interpret that? It says, what is the maximum possible area of the pen? 50, 2,500 was the ordered pair, correct? XY, again. What does X stand for? X is like the length of one of these sides. What does Y stand for? Isn't Y basically A in this case, correct? So which one's the area? So that'd be 2,500. And then the label would be, what were we in, feet? So is it feet, square feet, or cubic feet? It's an area, square feet. What are the dimensions of the pen? Well, I know X is 50, right? So it would be 50. And then if I put 50 in for X right here, what's 100 minus 50? 50. So 50 feet by 50 feet. And maybe you remember from geometry that to maximize an area, you want to have the shape become as regular as possible. And regular means all sides the same and all angles the same. Wouldn't that be a square if it's a rectangle with 4 equal sides? Yay. Oh, yeah! We're going to do this quick because you should have learned about a lot of this on the video, right? How to solve a quadratic equation. There's 5 things to look for. I've got them in an order of a hierarchy. The first thing, the easiest thing to look for of how to solve a quadratic equation is called the square root method. The only time you can use it, though, is when there's no x to the firsts. Is that a quadratic equation? Yes or no? It's not in standard form. It's not in vertex form. Is it an equation? Yes or no? Yes. Is the biggest exponent in there a 2? Yes or no? But you also see that there's no x to the firsts in there at all. How would you solve for x? You would square root both sides, correct? You would say x equals plus or minus 2 because you did the square root method. There was no x to the firsts in there, square root method. Second thing to look for is if you could factor it. I made a little tree for you. If there are 2 terms, the only way, I shouldn't say the only way, the most popular way to factor something that has 2 terms is a difference of squares. For example, isn't that a perfect square? 4x squared. Isn't this a perfect square? Correct? And they are being subtracted. The difference of squares factors into conjugates. You might make a note for yourself. They factor into conjugates of each other. That's a cool word. Conjugates. Meaning that would have factored to 2x plus 3 and 2x minus 3. Conjugates. It almost looks like the exact same thing in both ordered pairs, but what's the difference between those 2 bad boys? The sign. Cool. 3 terms, the first thing to look for is if it's a perfect square trinomial. I've typed it out for you already. How do you know if something's a perfect square trinomial? The first term's a perfect square, the last term's a perfect square, and the middle term is twice the product of the square roots. We'll come across those later. The next easiest thing after that is if it's easily factorable. That's when the a value is 1, which you had on your homework that was due today. And then the last way to factor, the way that sucks the most, it's called frowny face for a reason because it sucks. It's called frowny face factor. At least that's what I call it anyway. If you cannot factor something, That doesn't mean you can't solve it. Not every quadratic equation can be factored. The next thing we would look for is to complete the square, but there's only a certain time when I'd want to complete the square, because you can complete the square on anything, but it sucks a lot of times. It does not suck if A is 1 and B is even. The only time you can complete the square is if A is 1. That always has to happen. If B is an even number, it'll be very, very easy to do. And when would I do it? When that happens and it's not easily factorable in the first place. If completing the square is not an option and factoring is not an option, then I would go with the quadratic formula, which I want us to write right here. The quadratic formula is x equals, what is it? Let me erase this little nugget out of my way. The opposite of b plus or minus square root of b squared minus 4ac, and all of that is over 2 times a. And when would I use the quadratic formula? I mean, it works every time, but sometimes it's just a mess. It's just way too long. If you can factor something, it takes you 3 seconds. You know, do the quadratic formula, it takes too long. When would I use it? When the numbers are really large, even if some of these work, but when there's really big numbers, I'd rather use the quadratic formula, because I don't want to find 2 numbers that multiply together to be 3,085 and add together to be 264. It's like, I just don't want to do that. You know, it's like that's way too big of numbers. Finally, you could use your graphic calculator to, when you need an approximate answer, like in a story problem, like with our graph that we just had of this ball going down, you know, you could just calculate where it crosses the x-axis, because that's what you're doing. You're figuring out when x equals 0. You're finding the x-intercepts. So, boom, you're finding the roots, all that stuff. Boom! Let's go through it. Here's examples of each kind. Square root method. How do I know I can use the square root method? There are no x to the firsts. Would you agree? In this problem, there are no x to the firsts. Get x squared all by itself on one side of the equal sign. Wouldn't you have to add 7 to both sides? Right? Then, to solve, since x squared is all by itself, square root, you got to realize that you get 2 answers, though. 7 is not a perfect square, so I will just leave him as plus or minus the square root of 7. Any questions about the square root method? Only time you can use it is if there's no x to the firsts. GCF is the next method. That stands for greatest common factor. Look here. Doesn't everything have a multiple of 5 in it? Doesn't it also have a multiple of x in it? So I will take out a factor of 5x. Right, 5x is the greatest common factor. It's like the reverse distributive property is really what's going on here. If you take 5x squared and divide it by 5x, you will get 1x back. Minus sign comes down. 20 divided by 5 is 4, and x's cancel each other out. Cool. And now you use the zero product property to solve this. So what value of x makes him 0? X could equal 0. Or what value of x makes this quantity come out to be 0? 4. There's our 2 solutions. If you totally graph this, take a guess what happens. That parabola crosses the x-axis at 0 and 4. These are the x-intercepts of the graph right here. Next guy, perfect square trinomial. Right, that's what PST stands for. First term's a perfect square. Would you agree? Bring down his square root right here. 2x. Isn't that the square root of 4x? Is the last term a perfect square? 9? You bet. What's the square root of 9? 3. But don't put a sign yet. You need to bring down this guy's sign. Whatever sign that is goes right here. That factors into that entire quantity squared. If my pen would wake up, sorry. It's still equal to 0. Let's double check, though. Let's see if he really was a perfect square trinomial. I told you it was a perfect square trinomial. But to be a perfect square trinomial, first guy's got to be perfect square, check. Last guy's got to be perfect square, check. And then the middle term has to be twice the product of those square roots. If you multiplied those together, wouldn't you get 6x? Double it, don't you get 12x? Isn't that twice the product of those square roots right there? Cool. And now to solve this, you use the square root method. Because you've got an entire quantity being squared, you just square root both sides. This turns out to cancel each other out. You're left with 2x plus 3 equals. The square root of 0, there's no need to put plus or minus 0 because it's just plain old 0. Awesome. Then you solve for x. Subtract 3 to both sides and divide by 2. And this parabola crosses the x-axis at -3/2. It only crossed in one place because that means the vertex is touching the x-axis right there. This is also a perfect square trinomial problem right here. But the difference is, oh no, it's not equal to 0. Don't get it equal to 0. Because this is a perfect square trinomial. Notice the first term's a perfect square. What's his square root? 4x. The last term is a perfect square. A lot of people forget about 1 being a perfect square. Square root of 1 is 1, correct? Then I need to bring the sign down. Wait a minute, this isn't a perfect square trinomial. Well, let's change it to be a perfect square trinomial. Let's call that 8x right there. My bad, I made a typing mistake. Let's call that 8x instead of 32x. Y'all cool with that? Is the middle guy twice the product of the square roots? Now it is. And it's still equal to 11. Awesome-o? Still equal to 11. Sorry for the typo. What do I need to do to solve? Square root both sides. This guy becomes 4x plus 1. On the right side, now you need plus or minus the square root of 11. Get x all by itself. Let me subtract 1 from both sides. Negative 1 plus or minus the square root of 11. So far, so good. Divide by 4 to both sides. X equals negative 1 plus or minus the square root of 11 all over 4. Just like if you do the quadratic formula on that one, that's what you get for your answer in the quadratic formula. This was faster, in my opinion, if you understand the perfect square trinomial stuff, which I know that's pretty new to you guys. Okay? Difference of squares. It's a subtraction problem. There's only 2 terms on the left side, and both of those things are perfect squares, correct? They factor into conjugates of each other. Make yourself 2 parentheses times each other, equal and 0. All you got to do is square root each thing. What's the square root of 4x squared? It's a 2x. He goes at the beginning of each quantity. Square root of 9 is 3. It goes at the end of each quantity. And what you need is just to alternate the signs. It doesn't matter which one's which. One of them is a plus, and one of them is a minus, baby. Now we solve this with the zero product property. What value of x would make this turn out to be 0? Opposite of this over this. What's this number's opposite? Negative 3 over 2. That would make this 0. Or, what value would make this guy turn out to be 0? Opposite of this number over that one. What would you get? 3 over 2. That's where this thing crosses the x-axis. Please do that on the other difference of squares. This is a subtraction problem. There are only 2 terms, and each term is a perfect square. That's why it is a difference of squares. So set them up as 2 parentheses equal to 0. Square roots go in. 7, 7. Signs are different. It doesn't matter which one's positive, which one's negative. They just have to be different. Then to solve, opposite of this guy over that guy. Opposite of this guy over that guy. When you have a difference of squares situation, your 2 answers should be the exact opposite of each other. Cool? Awesome. We're getting closer. Easily factorable. A value is 1. Find 2 numbers that multiply together to be 12, add together to be a negative 7. The hardest part about that is finding the 2 numbers. So you need to think about the signs first. If they multiply together to be 12, should the numbers both be positive, both be negative, or one of them be negative? Well, you know they can't one of them be negative because they have to multiply together to be a positive, correct? Let this sign tell you what's going on. 2 positive numbers cannot add up to be negative 7, correct? So it has to be 2 negative numbers. What are 2 negative numbers that multiply together to be 12 and add together to be negative 7? Negative 3, negative 4. Doesn't matter what order they go in. Simply factored into those 2 quantities. That's why it's called easily factorable, because you don't have to go through that whole mess of splitting it up and factoring it by grouping. Solve for x. X could equal 3 or 4. What value makes this 0 if x was 3? What value makes that one 0 if x was 4? Frowny face factor. Ah! Why? Because the a value is not 1. So I make that little frowny face and I multiply a times c, negative 8. Correct? Now I need to find two numbers that multiply together to be negative 8 and add together to be a negative 9. Since they have to multiply together to be a negative, would you agree that one number has to be positive and one number has to be negative? So multiples of 9, 1 and 9, but one of them has to be negative. Oh, multiples of 8, sorry. Multiples of 8, 1 and 8, but one of them has to be negative. Newt and Newt. I think I did this backwards. Neither one of those add together to be negative 9. Multiples of 8, 2 and 4, one of them has to be negative. Not going to happen. Multiples of 8, that's it. Another typo on my part. So, frowny face factor, I'll make up another example another day. But it was on your practice sheet, correct? My bad. Hey, that's what happens when you type these over the summer, you know? It's like, sorry, I'm watching Family Feud, and I'm trying to make a worksheet at the same time. Complete the square. Complete the square. Is A1? Is B even? And notice you can't factor this. You cannot find two numbers that multiply together to be a negative 3 and add together to be a 4. Because the two numbers that multiply together to be negative 3, these are your only combos. They do not add together to be 4. So, since A is 1 and B is even, though, completing the square is actually a pretty simple case. Set her up with blanks. X squared plus 4x plus blank. We also want to bring all the constants over to the other side, so we're going to add 3 over here and also put a plus blank over there. Why do you put a plus blank on both sides? Because you got to keep it balanced. If you're going to add a number to the left side, you got to add a number to the right side. How do you complete the square? Take half the b value. Reason why you want it to be even, because doesn't half of an even number come out nice? What's half the b value? It's 2. Then square it. What do you get? 4 goes into blank. 4 goes into this blank. If I add 4 to the left side of the equation, I have to add 4 to the right side. The reason why we did that is because this is now a perfect square trinomial. We are completing the perfect square trinomial. He factors very simply to be the square root of him and the square root of him and whatever sign you are right there, quantity squared. Same perfect square trinomial trick we did before. Square root of your first dude, square root of your last dude, sign comes in the middle, the quantity is being squared, and over here, don't you have a 7? 3 plus 4. Square root both guys. This becomes x plus 2, and this is plus or minus square root of 7. So far, so good? To get x all by itself, subtract 2 from both sides. And there's our answer. X equals negative 2 plus or minus the square root of 7. Let's do that one more time. Set it up with blanks. And then subtract that guy over also. A is 1, B is even, and this is not factorable, so that's why we're completing the square. How do you fill in the blank? Half the b value squared. What number goes in the blank? 9. This guy factors to x and to 3, quantity squared, and the sign is negative. Right, that sign right there is negative. Negative 11 plus 9. Uh-oh! How much? Negative 2. Uh-oh! SpaghettiOs! Now we have to square root both sides. When you square root this side and square root this side, this becomes x minus 3, and this can't happen in the real number system. But luckily, we know about imagination land. What is the square root of negative 2? It's square root of negative 1 times the square root of positive 2. But what's the square root of negative 1, my friends? It's I square roots of 2. That's what you have, and then you got to have plus or minus also. Plus or minus I square roots of 2. Cool? Then add 3 to both sides. X equals 3 plus or minus I square roots of 2. In the real number system, Depending on what my math lab says, you'd say no real solutions. In the complex number system, we'd have this. And then the quadratic formula, let's realize why you would use the quadratic formula on this. Maybe, just maybe, it was factorable. But would you really want to take 3 times negative 35, get that big old number, and find two numbers that multiply together to be that and add together to be negative 14? It would take you too much time. By the time you did the quadratic formula, you'd be done. You just substitute, since A is 3, B is negative 14, and C is negative 35. You substitute those into the quadratic formula and find your two answers. Good?